1, 2, 3, 4. I get my first substituent and only substituent off carbon number 4, so it's going to be a 4 something. It's hard to name this the one without using the IUPAC rules. This is always carbon number 1 when you have a substituent, so it's going to be a 2-fluoroethyl. Put that all together, I get a 4-2-fluoroethyl. 4-2-fluoroethyl heptane. Okay? How about this one? Okay. If I look at my long parent chain here, it's going to be a cyclohexane ring. And then we need to decide which one of these substituents, bromine or fluorine, has the highest priority. It turns out that if we do this, we give bromine the highest priority only because it's alphabetical. Not because it weighs more, not because it's got a bigger atomic weight. So the rule for IUPAC nomenclature for halogens is just alphabetical in this case. So that's why we're calling this carbon number 1 and this carbon number 3. 1, 2, 3. I could have gone 1, 2, 3, 4, 5. But going around the one way gives me the lowest possible numbers. That's what you're shooting for. Lowest possible numbers for the positions. Okay? And then I look at this and I say, uh-oh, I have stereochemistry that's implied from these different wedges and dashes. So I'm also going to have to include stereochemistry in my answer. So if I look at this, I'm going to have a 1-bromo, 3-fluoro cyclohexane. I'm going to have to include stereochemistry, R or S. So I need to determine that that's priority 1, priority 2, priority 3, priority 4. So that should be an R. So it's going to be a 1R. If I look at this one here, fluorine is my highest priority, my lowest priority. Good thing you're all pointing in the back, right? Okay. 1, 2, 3, so that's going to be an S. So this one, putting all of that information together, I get R, I get S, put those together, I get 1R for the bromo, 3S for the fluoro, okay, and then 1-bromo, 3-fluorocyclohexane. Notice that I put the stereochemistry out in front, and I actually numbered them, and then put the letters for the different stereochemical nomenclature. So altogether, 1S, 1R, 3S, 1-bromo, 3-fluorocyclohexane. Let's do some more, because they're so much fun. In fact, this time, let's do the common names too at the same time. If we looked at IUPAC names, we typically think of those as haloalkanes, because we name the halogens as the substituents. The common names are sort of just the opposite. We name them as alkyl substituents on a halogen. And the reason we still do that is because it's sort of a legacy thing. People have those names around still, and we still use them, because it goes way back to the 1800s when all the Germans were doing chemistry, okay? So let's look at this one. If I named it by the IUPAC system, I would have called this fluoroethane. Do I have to put a 1 out there? I could, but it would just be redundant, because if it was over here, it would still be 1, right? If I had a second substituent off of here, like a chlorine, then I would have to name it 1, okay? So in this case, fluoroethane. Let's name it as if it's an alkyl halide in this time. So here's my alkyl group. It's going to be an ethyl fluoride, okay? Notice that now I don't call it fluorine. I make it an I because it's an alkyl halide, okay? That's the common nomenclature system. How about this one? In this case, for the IUPAC system, it's going to be a butane. It's going to be a 1-chlorobutane. Do I have to use the 1 in this case? Yes, because it could be a 2-chlorobutane, right? So I have to, in this case, include the 1 on there. Otherwise, it is not correct, and you don't know if it's 1 or 2-chlorobutane. Okay? How about the alkyl halide? This is going to be a chloro, so I'm going to name this a butyl chloride. And I also put N in there. Remember, N means that it's a terminal, it's a straight chain carbon, because butanes can be iso, they can be neobutanes too, and so that's why I have to put the little N in front of there. And that's the common name. N-butyl is the substituent. Fluoride is now my halide right there. This one here, I actually have a propyl group, so this would be 2-bromopropane would be my IUPAC system. If I wanted to name this as an alkyl halide, I'm gonna name it as a bromide. And then I gotta decide what to call this, okay? I know it's a propyl, but if I look at that, where is the bromine sort of attached to the middle? I sort of have this V structure here, so we call it isopropyl, okay? So this is isopropyl bromide. It's a very common term, okay? If I look at this one, I can actually give it IUPAC name, because the biggest ring is gonna be a 6-membered ring. It's gonna be iodocyclohexane. 1-iodocyclohexane? It doesn't matter, as long as I only have one substituent, right? So it's iodocyclohexane. The common name, I'm gonna call this iodo compound, so I call it cyclohexyl iodide, just like that, okay? And finally, let's do this one. This one's more complicated because it's got some stereochemistry involved. I'm gonna have to, in this case, I'm gonna have to use R and S again, so I gotta determine it. This is a 5-membered ring. That's my longest continuous carbon chain, so this is gonna be a cyclopentane. I have 2 substituents. I have a methyl and a chloro. Which one should I start with, chloro or methane, if I number the system? Let's start with chloro, because it comes first in the alphabet, okay? So this is gonna be 1 chloro, 1, 2, 3, 3 methyl pentane, and now I have to actually identify the stereochemistry here. If I look at this one, I go, this group is my highest priority, this group here is second, this group here is third, my hydrogens are back. So this is gonna be an R chloro. This one here is gonna go, is in the back, I go 1, 2, 3, but because the hydrogen's out in front, I call it an R also. So this should be RR, so it should be a 1R, 3R, 1 chloro, 3 methyl cyclopentane, or really simply, we could call this trans 2. Okay? That's sort of mixing up the different nomenclature systems, but if you looked out there, lots of times they'll just call that trans, even because there's only 2 groups on it and they're sort of on the opposite sides of the ring. It's a little more complicated than that. So if you use the R and S as we just described, 1R, 3R, 1 chloro, 3 methyl cyclopentane, you're always going to be right. You don't have to guess at system. Yes?